Hi there, future scientists and math wizards. Welcome to Smile Road. I'm Sir M, and I created this channel just for you, senior high school students looking to make science and math easier, clearer, and yes, even more fun. On Smile Road, we explore exciting lessons in general science, solve real life problems in general mathematics, and learn how these subjects connect to the world around us, from floating boats to your monthly budget. Each meeting, I'll guide you through lessons using simple explanations, real life examples, and even a few challenges to keep your brain sharp. Whether you're reviewing for exams, catching up on class topics, or just curious about how the world works, you're in the right place. Don't forget to hit that like, subscribe, and notification bell so you won't miss any of our learning adventures here on Smile Road. So, are you ready to start this journey with me? Let's walk the road of knowledge with a smile. Our topic for today is about finding the area of oblique triangles using Heron's formula and the Sine Rule. Practice problems together with the MCQ. This is quarter 3 of grade 11, General Mathematics, about measurement and geometry. Again, this is quarter 3, measurement and geometry, lesson Roman numeral number 2, finding the area of oblique triangles using Heron's formula and the Sine Rule. Intended learning outcomes. By the end of the lesson, the learner should be able to A. Illustrate the area of oblique triangles using Heron's formula and the area rule involving sine. Solve problems involving the area of oblique triangles using these methods. Appreciate the application of these formulas in real-world scenarios such as surveying or architecture. Area of oblique triangles. An oblique triangle is any triangle that does have a right triangle, that doesn't have a right triangle. This means it can be either an acute triangle or an obtuse triangle. When we say acute triangle, all angles are less than 90. When we say obtuse triangle, in our oblique triangles, one angle is greater than 90 degrees. Unlike right triangles, where the area is straightforward, 1/2 times the base times the height, calculating the area of oblique triangles requires different formulas since the altitude is not always readily available. Area formula with sine. So this method is used when you know the lengths of the two sides and the measure of the included angle, the angle between the two known sides. So letter C, the formula is a modification of the standard area formula. The three forms of this rule are area is equals to 1/2 times small letters A times B times sine of angle C. Take note that small letters A and B, these are the sides of our oblique triangle. And then angle C, which is in capital format or uppercase. This is the included angle of the sides, side A and side B. Take note, you have side A and B, and then of course, you have the angle C in capital letter. So take note of that formula. Next, if the two sides B and C, small letters B and C are given, and the included angle of that, of course, is angle A, so the formula will be area is equals to 1/2 times small letter B times small letter C times sine of capital letter A or angle A. Okay, next, number 3. In this formula, sides A and C, these are small letters A and C. And the included angle of that, of course, the missing letter is angle B. So, we need to use a capital letter for angle B. And the formula for the area will be area is equals to 1/2 times small letter A times small letter C times sine of angle B. Here, small letters A, B, and C represent the lengths of the sides, and the capital letters A, B, and C are the angles opposite those sides. This formula is derived from the standard area formula. Area is equals to 1/2 times the base times the height. In a triangle, the height can be expressed in terms of one of the sides and the sine of an angle. For instance, if you consider side A as the base and the height would be B times sine angle C. Substituting this into the standard formula, it will give you area is equals to 1/2 times the A times the B times sine of angle C. So this method is extremely useful because it directly relates the sides and angles of a triangle to its area. Heron's formula. This formula is used when you know the lengths of the three sides of the triangle. It's especially useful when no angles are known. So the formula involves a preliminary calculation called the semi-perimeter. And the steps in obtaining the area of an oblique triangle without any angle given. So calculate the semi-perimeter S, which is half the perimeter of the triangle. So S is equals to open parenthesis A plus B plus C close parenthesis divided by 2. And then use the semi-perimeter or semi-perimeter to find the area using Heron's formula. And the formula is area is equals to the square root of S times S minus A times S minus B times S minus C. Heron's formula is a powerful tool because it allows you to find the area of any triangle regardless of its shape, as long as you have the lengths of all three sides. Letter D. It's an ancient formula that provides a direct path to the area without needing to find any of the angles or the height. This is particularly valuable in practical applications like land surveying, where measuring the lengths of the sides of a triangle plot might be easier than measuring its angles. So both methods are essential for a comprehensive understanding of oblique triangles. The choice of formula depends on the information you are given. If you have two sides and the included angle, use the sine rule. If you have all three sides, use Heron's formula. So the area of triangle, so we have triangle A, B, and C. And then all in capital letters and in red colors. And we have sides A, B, and C all in blue colors. So the formula A is equals to 1/2 times AB times sine of the included angle C. Using Heron's formula, determine S. S is equals to A plus B plus C all over 2. And to get the area, it is equal to square root of S times S minus A times S minus B times S minus C. What is an oblique triangle? So an oblique triangle is a triangle with no sides that are equal. So here, the area of the right triangle, as we know, is 1/2 times the B times the height. And the height can be determined using the sine of the angle. So the area of an oblique triangle using the sine rule is, the first one is 1/2 BC sine of the included angle A. A is equal to 1/2 sides AB times sine of the included angle C. And then A is equal to 1/2 the products of the side A and side C multiplied by the sine of the included angle, which is B. Finding the area of an oblique triangle using the law of sines. So area is equal to 1/2 BC times sine of angle A. So using SAS, side, angle, side. So this is what we call the area at oblique triangle, the sine rule. So area is equal to 1/2 BC sine angle A is also equal to 1/2 AB sine angle C, also equal to 1/2 AC sine B. So here we use SAS, the side, angle side, side, angle side. We will have the next part of this lesson, Quarter 3, MG, Lesson Roman numeral number 2.